December 6, 2025. NASA loses contact with MAVEN. But 8 weeks earlier, this Mars orbiter photographed something that changes everything. On October 9th, MAVEN captured 3I/ATLAS at 56 million kilometers, revealing a massive hydrogen cloud that shouldn't be there. Harvard's Avi Loeb confirmed it. Perfect operation, one photograph, then total silence. What did MAVEN see in that image? And why did our most reliable spacecraft go dark immediately after? Let's dive right in. MAVEN, the Mars Atmosphere and Volatile Evolution spacecraft, launched in November 2013 and has been orbiting Mars since September 2014. That's over 11 years of continuous operation. This isn't some experimental satellite that might glitch out. It's been our reliable set of eyes on Mars, relaying data from Curiosity and Perseverance on the surface, monitoring atmospheric conditions, and executing thousands of successful operations. Engineers trust MAVEN the way you trust the sunrise. On October 9, 2025, Mission Control tasked MAVEN with a special assignment. Photograph 3I/ATLAS as it passed within 56 million kilometers of Mars. It was a perfect opportunity. The object was close enough for decent resolution, and MAVEN's ultraviolet spectrometer could capture details that Earth-based telescopes might miss. The spacecraft executed the command flawlessly. The image came through. Scientists downloaded the data. And that's when everything changed. The photograph revealed something that didn't make it into NASA's public release in any meaningful way. A massive hydrogen envelope surrounded the object. Not a thin halo, but a substantial cloud of atomic hydrogen extending far beyond what you'd expect from a small comet. Avi Loeb, the Harvard astronomer who's been studying interstellar objects since Oumuamua, pointed this out just 2 days ago. For something supposedly only 400 meters across, that hydrogen signature was enormous. Disproportionate. Wrong. MAVEN continued its normal operations after sending that data. For 58 days, everything was fine. Then, on December 6th, silence. The Deep Space Network, NASA's array of giant radio antennas designed to communicate with distant spacecraft, started listening for MAVEN's regular check-in signal. Nothing came through. They tried commanding the spacecraft. No response. They checked every frequency, every backup system, every possible explanation for a communications glitch. Total radio silence from a spacecraft that had been perfect for 11 years. Now, spacecraft do fail. Solar panels degrade, electronics get hit by cosmic rays, systems break down. It happens. But think about what MAVEN had just done. It photographed an interstellar visitor showing anomalous hydrogen emissions. It transmitted that data successfully. Then it went dark. If this happened with any other spacecraft at any other time, you'd call it bad luck. But the timing creates a pattern that's impossible to ignore. And while NASA works to re-establish contact with MAVEN, 3I/ATLAS is getting closer to us. Right now, it's approaching its nearest point to Earth, December 19th, just 5 days away. At 270 million kilometers, it's not close by human standards, but astronomically speaking, it's a stone's throw. Close enough that amateur astronomers with serious equipment are trying to observe it. And here's what they're finding. Almost nothing. The object is magnitude 11 to 12, which means it's incredibly faint. You need at least a 120mm telescope aperture just to see it as a dim smudge. Professional observatories with much larger instruments are struggling to get clear images. For an active comet, something that's supposedly spewing gas and dust as it heats up near the sun, this is bizarre. Comets are usually bright. Hale-Bopp was visible to the naked eye for months. Even small comets create impressive displays when they're active because their tails reflect sunlight beautifully. 3I/ATLAS is doing the opposite. It's dark. The albedo, the measure of how much light an object reflects, is extraordinarily low. It's absorbing light rather than reflecting it. Think about what that means for a moment. Comets are made of ice and rock. Ice is reflective. Dust is reflective. Yet this object, which is supposed to be a dirty snowball, is darker than asphalt. But it gets stranger when you look at how it's moving. When astronomers first detected 3I/ATLAS, it was traveling at 221,000 kilometers per hour relative to the Sun. That's fast, but perfectly normal for an interstellar object falling into our solar system's gravity. As it swung around the Sun at its closest point, what astronomers call perihelion, it accelerated to 246,000 kilometers per hour. Most of that speed increase comes from gravity. When you fall towards something massive like the Sun, you speed up. Basic physics. But there's a problem. The acceleration doesn't match gravitational models perfectly. There's extra push. Astronomers have a technical term for this: non-gravitational acceleration. It means the object is somehow propelling itself. For normal comets, this is easy to explain. The Sun heats the ice on the comet's surface. That ice doesn't melt. There's no atmospheric pressure in space. It sublimates, going directly from solid to gas. Those jets of gas shoot out into space, and Newton's third law takes over. For every action, there's an equal and opposite reaction. The gas jets push the comet, changing its trajectory slightly. We can see this happening. Comets develop spectacular tails, millions of kilometers long, glowing beautifully as the Sun's radiation ionizes the gas. So where's the tail on 3I/ATLAS? If it's generating enough thrust to accelerate a 400-meter rock, and we're talking about significant force here, we should see massive outgassing. We should see a brilliant tail. We should see it lighting up the night sky. We don't. We see a dark object barely visible to our best telescopes, somehow pushing itself without any visible means of doing so. Avi Loeb has been asking this exact question since Oumuamua passed through our solar system in 2017. That object also showed non-gravitational acceleration without visible outgassing. Loeb called it excess push and suggested we should consider the possibility of artificial origin. The scientific community largely dismissed the idea, but now we're seeing the same pattern repeat with 3I/ATLAS. Same unexplained acceleration, same lack of visible propulsion, same dark, stealthy profile. And this brings us back to that hydrogen cloud MAVEN detected. Hydrogen is the most abundant element in the universe. It's also fuel. This isn't science fiction, it's actual aerospace engineering theory. If you were designing an interstellar probe to travel between star systems, you wouldn't carry all your fuel with you. The mass penalty would make the mission impossible. Instead, you'd design a Ramscoop system, harvesting hydrogen from the interstellar medium as you travel. Or you'd refuel at convenient locations along your route, say planetary atmospheres rich in hydrogen. MAVEN detected 3I/ATLAS, surrounded by a massive hydrogen envelope at 56 million kilometers from Mars. That's well within the range where Mars's upper atmosphere extends into space. The timing is striking. The object passes near Mars. It's enveloped in hydrogen. MAVEN photographs this. 8 weeks later, MAVEN goes silent. Did MAVEN witness something it wasn't supposed to see? Did it catch this object in the act of refueling? I know how this sounds. I know the default assumption should be natural explanations. Space is full of weird phenomena we don't fully understand yet. But we're not talking about one anomaly here. We're looking at a pattern: dark object, unexplained acceleration, hydrogen envelope, silent spacecraft. And while optical telescopes struggle to track this dim visitor, something else is happening that barely anyone is talking about. Radio telescopes are listening. The Green Bank Telescope in West Virginia, one of the world's most sensitive radio observatories, has been pointed at 3I/ATLAS's coordinates. So has the Deep Space Network when it's not trying to contact MAVEN. These are instruments designed to detect electromagnetic radiation, to search for signals in the cosmic noise. You don't aim billion-dollar radio telescopes at a simple chunk of ice unless you expect it to emit something interesting. There's a concept in SETI research about how advanced civilizations might use probes. Instead of sending signals across interstellar distances, which requires enormous power and takes centuries, you send physical probes. Those probes stay dark and silent during transit to avoid detection and conserve energy. But at critical moments, closest approach to a star system, closest approach to a potentially habitable planet, they wake up, they scan, they transmit data back home, or they send a signal to the target civilization. December 19th is that moment for 3I/ATLAS and Earth. At 270 million kilometers, it's close enough for a sophisticated probe to conduct a detailed scan of our planet. Close enough to analyze our atmosphere for industrial pollutants, detect our radio and television broadcasts, map our electromagnetic signature. All the techno-signatures that scream, "Intelligent life is here." Is that why radio astronomers are suddenly interested in tracking what NASA calls just another rock? Are they expecting something to happen on the 19th? I want to show you one more piece of this puzzle, because it's subtle but significant. NASA released updated orbital parameters for 3I/ATLAS yesterday. These are the precise calculations of where the object is and where it's going. But if you look at the timestamps on that data, there are gaps, hours where the tracking simply stops. The official explanation is routine maintenance on the Deep Space Network, scheduled downtime for equipment calibration. But here's what doesn't make sense. Professionals who track satellites for governments and private companies are saying you don't lose coverage of a high-priority object like this. The Deep Space Network has redundancy built in, specifically to prevent gaps. Multiple stations around the world ensure continuous coverage. You can always hand off from one antenna to another. Yet the gaps persist in the tracking data for 3I/ATLAS. We're now 120 hours from the closest approach. 5 days. The official story hasn't changed. It's an interstellar comet, mildly interesting to astronomers, completely harmless. But when you line up everything we actually know, MAVEN's photograph, MAVEN's silence, the dark object, the unexplained acceleration, the hydrogen cloud, the radio telescopes listening, the gaps in tracking, it creates a picture that's very different from the press releases. I'm not saying I know what 3I/ATLAS is. I'm saying the data we have doesn't match what we're being told. And in 5 days, we're going to find out if December 19th is just another day, or if it's the day that changes everything. So here's where we stand. MAVEN photographed a massive hydrogen cloud around 3I/ATLAS on October 9th. 58 days later, it went silent. Now that same object is 5 days from its closest approach to Earth, accelerating without visible propulsion, darker than it should be, and radio telescopes are listening for something. Each piece of evidence by itself could be explained away, but together they create a pattern that demands answers. What did MAVEN actually see in that photograph? Why did a flawless spacecraft go dark right after observing this object? And what happens on December 19th when 3I/ATLAS reaches its nearest point to us? I'll be tracking every development over the next 5 days. If you want real-time updates on what's actually happening, not just what the press releases say, subscribe to Galactic Breaking News and hit that notification bell. This story is moving fast, and you don't want to miss what comes next. Drop a comment below. Do you think MAVEN's silence is just coincidence, or is there something bigger happening here? Hit the like button if you want more coverage like this, and share this video with anyone who's paying attention to what's really going on. December 19th is coming. Let's watch it together. I'll see you in the next update.